All right, this is a continuation of section 7.3, and we are in the middle of solving systems of equations using matrices and the row echelon format, where you have your back substitution. All right, this is my matrix here. I'm taking my system of equations. There's 4 equations. I make the matrix, pull out your coefficients, make sure you place 0 in all the place that you would need to. We're going to use this 1 here to get rid of the 1, the 2, and the 3. So let's do the 1 first. You're going to do negative row 1 plus row 2. And our result is 0, 1, negative 1, and 2. All right, our next step would be to get rid of negative 2 on the row 3. And so we're going to do negative 2 row 1 plus row 3. All right, let's look at our results. So we've got negative 2 plus 2 is 0. 2 plus negative 3 is negative 1. Negative 4 plus 5 is 1. And negative 8 plus 4 is negative 4. All right, now next row, we are going to take negative 3 times row 1 and adding it to row 3, and that's going to replace row 3. Here's what we got. Negative 3 plus 3 is 0. 3 plus 2 is 5. Negative 6 plus negative 1 is negative 7. And negative 12 plus negative 1, or plus positive 1, is negative 11. All right. We are going to be moving on now. So my second row is stable. That's what I'm going to call it. It's not going to change at all. Now let's figure out how we are going to use this 1 here in row 2 to get rid of the 1 and the negative 1 and the 5. So let's get rid of the negative 1. We're going to take row 2 and just add it to row 3. Let's see what our results are. 0, 0, 0, and negative 2. So here we run into a problem. We've lost all of our variables. There's no way to get that variable of z back. So we have 0 equals negative 2. This is a no solution. No solution. All right, let's go ahead and move on and see what we have here for our next example 4. Solve the system of equations with infinite solutions. All right, so I take my system, I make a matrix, and now I'm going to use the number 1 to get rid of the 2 and 3. Here's what we got to do. Negative 2 row 1 plus row 2. And again, if you need to pause and be able to take some time to write this down, please do so. That is 0. Negative 2 plus 3 is 1. Let me change colors here. 0 and then 1. Negative 2 plus 1 is negative 1. And 0. 0 plus 0. And then what we'll do is take negative 3 row 1 and add it to row 3. So we get 0. Negative 3 plus 5 is 2. Negative 3 plus 1 is negative 2, and 0 plus 0 is 0. All right, our next step would be to consider this number 1 right here and get rid of the 2 that follows below it. So that would be negative 2 row 2 and then we're going to add it to we're adding it to row 3. And so we've got 0. This is my second row, and obviously it's not changing, but now I'm going to change my third row. 0 plus 0 is 0. Negative 2 plus 2 is 0. 2 plus negative 2 is 0, and 0 plus 0 is 0. And so right here, we get many solutions. So we automatically go right to saying that, okay, so z is equal to a. And if I go to find my y, it would be y minus z normally, but so put in a equals 0, so y is equal to a. And then on top you have x plus my y, and my y is a, plus my z, and z is a, equals 0, so x would equal negative 2a. So final solution here, negative 2a, a, and a. And that's it. All right, so that completes that problem, and that's how you do with many solutions. You always need to include your a's. Just automatically set z equal to a, and then from there you can do the back substitution. All right, the last thing that we're going to look at here is something that's called reduced row echelon form. And reduced row echelon form is when you have all of your diagonals right here are 1, and you can see all other elements outside of these answers right here. Everything else is a 0. 0, 0, 0, 0. So all of the components are 0 except for the diagonal ones. And what this indicates, if you get it to this point, then these are your solutions. This is your x solution, this is your y solution, and this is your z solution. So what we're going to do is we're going to take a look at that example 1 again. We're going to start off in the form that we had reduced it down to the row echelon. So after we did the stair step and with our matrices, I can take you back to that problem. It is right here. So once we have this matrix right here, we're copying that over to finish this last problem. Okay, so here's how it works. Once you get your zeros in the bottom positions and you have your diagonals equal to 1, we want to separate the last 3 digits here with the rest of the matrix. Now our goal is to get a 0 here, a 0 here, and a 0 there. And so we do the same process, we just work backwards a little bit. In order for me to allow negative 2 in the first row to go to 0, I can use row 2 and add it to row 1. Okay, so what we would do is we would go 2 times row 2 and adding it to row 1. We're just adding in reverse order. We're adding to the above equation. And let's see what we get. So this time around, I'm not changing my middle row. And obviously I'm not changing my end row because that's actually in the position that we want it to be in. But I'm going to change my first row. Okay? And so if I take row 2 times 2 and add it to row 1, I get 0 plus 1 is 1. 2 plus negative 2 is 0. 6 plus 3 is 9. And take again 2. So the 5 times 2 is 10 plus 9 is 19. All right, now what we're going to do is we're going to take this 1 in row 3 and use it to get rid of the 3 and to get rid of the 9. And let's just go ahead and do this in one step. All right. Here's what we've got. We've got 0, 0, and 1. These are the spots that are not going to be changing. All right, so I want to take row 3. So here's what we're going to do. We're taking row 3, and we're going to multiply it by negative 3, and we're going to add it to row 2, and we're going to replace row 2. All right, we've got 0 then plus 0 is 0. 0 plus 1 is 1. Negative 3 plus positive 3, we're replacing this to be 0. And then negative 6 plus 5 is negative 1. And so again, that third row doesn't change. I replaced my middle row, and now I'm going to go ahead and replace my final row, row 1. And in order for me to do that, I need to multiply row 3 by negative 9 and add it to row 1. Let's see what that last element is. Because we would get the 1, we would get the 0, and negative 9 plus 9 is 0. And multiply again here. So negative 18 plus 19 is 1. So here's what this indicates. If you get your matrix into this reduced row echelon, so reduced means then what you've got here is you also have zeros in the rest of these spots right here. That is reduced row echelon. So what we're able to conclude then is my solution is 1, negative 1, and 2. And what that comes from is this list right here. That's your x, your y, and your z just listed vertically. So that's how you do reduced row echelon form to solve a system of equations. Again, it's just one option. And here is your assignment for this section.